What's up my people, welcome back, and in today's video we're building the most powerful AI property recommendation engine that you've ever seen. Yes, you heard me right, it's really powerful because we're going to implement embeddings to perform semantic searches for the properties. So we're going to be using Voiceflow for the chatbot, Pinecone for the vector database to store the embeddings, and OpenAI to generate the property embeddings to do the search. So it's really powerful because someone can type in whatever they want in a property. Let's say I want a 3-bedroom, 2-bedroom house in the mountains with a swimming pool. Like, it's able to couple all this and get the most likely property that meets the user's requirements. So it's quite powerful because we're doing a semantic search. Let me stop talking and here's a demo. So here I've deployed the chatbot on my Voiceflow account. So Voiceflow is really nice because now they allow us to deploy the chatbot from the canvas. So here I've deployed it. So let's ask it a few questions, okay? I want a 3-bedroom, 2-bathroom house in the mountains. So let's see. Now it's doing a semantic search from our vector database to find properties that meet the requirements and sends them back. So you can see them here. Let me just scroll so that you can see more of them. All these properties, and I'll show you the property descriptions so that you can see that they're actually in the mountains. Okay, so for example, let's take this property. I'll just copy the address. So these properties are stored in Airtable database as well as the Pinecone vector database, and I'll go through all that, but let me just show you this on Airtable. So here I've searched the property, and if I go to the description itself, we're able to see that. So you can see located in the prestigious mountains. Going back, let's look at this 1409 Pine Avenue. You can see here in the description, nicely updated home located in the mountains. So you can see that. Then we can look at this 145 Millet Sir. You can see here in the description, you can see close to Pine Forest Road in the mountains. Okay, and you can perform a whole lot of functions. For example, viewing the property on Zillow. That opens a new tab where you can view the actual property. So you can see the property there. But going back, so it asks me, would you like to learn more about this property? But I guess we want to do more functions. So let's say viewing the house tour video. So I'll click on that. You can see the video there. I can play it. I can view it on Google Maps. Then I can click this to view it on the larger map. Then I can also learn more on this property. So then go ahead and ask anything in regard to this property. Let's assume I'm an investor, so I can be like, how much do you estimate I can rent out this property? Estimated rent is 5,112. What's the price? Price of the property is 407,500. And if I scroll up over here, I'm able to see that the price is 407,500. What's the property tax rate? That's 1.96%. Are there any schools nearby? Yes, there are schools nearby. The Wallingford Village School, which is 2.8 miles away, and Mill River USD. Now let's say I like this property and I want to buy. I want to buy the property. Awesome, I'll need a few details from you. First of all, what's your name? Mutiso Mwadhime. Mutiso the AI master at gmail.com. My phone number. You can hit me up. Awesome, kindly await. One of our agents will be in touch with you soon. And if I go to Airtable, which is in this case the CRM, you'll find that detail has been added. You can see it there in the buyers table. I'm able to see my name, email address, the phone number I gave, and the specific property ID that I'm interested in. Is there anything else I can help you with? Yes. Let's say I want to sell a property I have. I want to sell my current house. Great, we're here to make sure you get the best price. What is the address of the property? 2256 Left Street, Arizona. I've guessed all this, so it's not existing. What's the selling price you have in mind for the property? 300k USD. It's a nice house. Wow, that price range is perfect. You'll find the buyer. And what's your timeline for selling the property? 3 months. Thanks for the info. Kindly provide your name, Mutiso Mwadhime, and my email, Mutiso AI Master, and my phone number. Awesome, a member of our team will be in touch with you in a few. Do you need help with anything else? If I check the CRM, we should see that detail added. You can see here in the last record, the name, email, Mutiso AI Master, the phone number, and the property address, which is 2256 Left Arizona. And here you can see all these details. And now you're saying, this is nice and all, but how do I get into building one myself? Let me show you. So we won't touch much on the Voiceflow part because that we already covered in our last video. We did a video on building a powerful real estate chatbot, so go and check that out because most of these functionalities have been explained in there in depth. Okay, so in this case I wanted to mainly focus on the semantic search part, where we use Pinecone to store the property details and be able to perform a semantic search to get the most relevant properties. So this is the powerful part that I'm going to focus on mostly on this video. So here's the Airtable database containing the properties. So let me just show you the properties table. So it has 30 properties in here, you can see, and it has several columns like the city, state, home status, address, number of bedrooms, bathrooms, and all that, even the price and even the property description, all that. Okay, so what I'll do is I'll download the CSV of this so that we can be able to get right into it. Also, don't worry, I'll provide all the templates that we use. So the Voiceflow template for you to build this all yourself. I'll provide the code, the Python code that we use to perform the semantic search via Pinecone, and I'll provide any resource that you need to use within this tutorial so that you can follow along. So check link in the description to the GitHub so that you can be able to access the code and also be able to access the Voiceflow template. So let's download the CSV over here. So what I'll do is go to grid view over here, download CSV. So once that's downloaded, we'll go to the backend where we're performing the semantic search. So we're using Python Django to be able to handle everything in regards to the backend. So I'll go to that project. I'm hosting it on Project IDX, which is a Google form of competitor of Replit, or enabling you to host your code online. Okay, so I'll go through the project just quickly to show you the project. So here I have my folder project. Everything is within this folder called my site, and we have two folders, a API folder and the home folder. So most of the work is within the API folder because that's where we perform the semantic search, we configure our Pinecone vector database, we're able to create the vector embeddings for the properties and everything. Okay, so what I want to do is to add that specific file for the properties into this specific folder called API. Okay, so I'll just drag it in here over here, let it upload, then I'll rename it to properties.csv, rename properties.csv. Now that the properties.csv is up, let me just run the server. So for that, I'll open the terminal. So for that, I'll just do python manage.py run server. And you can notice also I've activated my virtual environment, which contains all the Python packages I'm using within this. On your side, ensure you install all the packages that we're going to use in this project. For that, you'll find a requirements.txt file that contains all that. So what you'll do is open your terminal, then run this command, pip install -r requirements.txt. So just that simple, but ensure you're within the folder that has this specific file. In my case, I'd have to first cd into my site, so enter into my site folder because that's where my requirements.txt is. But for you, run that command and it will install all the packages you need to use. Then you run the server. Then for this, I'll just click control, then click on this specific link to open it up in a new tab. You can see there you go. So this is a link we're going to use so that you can be able to make an API call to create the embeddings, make an API call to perform the semantic search of the properties and any other functionalities we need to handle. Okay, so we'll get back into this. Okay, so let me go to the actual APIs folder, then go to the function that's handling creating the vector embeddings, because now we have the properties CSV. We need to convert them into embeddings that we can store in our Pinecone vector database. That's in views.py. So to create the embeddings, we're using OpenAI. For that, you'll need to have an OpenAI API key. So what you'll do is go to platform.openai.com. So if you don't have an OpenAI account, ensure you create the account, then log into your dashboard. Then go to, it will take you here to platform.openai.com. Then you'll click on dashboard over here, then API keys, view user API keys, scroll down, create new secret key, give it a name, whatever it is, create secret key, then copy it and save it somewhere because you'll use it within the project. Okay, so you can save it within your project here, but I'd advise to save it in environment variables. Okay, so this is the API that handles creating the property embeddings. Then we store the embeddings into a CSV file that we will later upsert into the Pinecone vector database. So I'll go through that step by step. So first of all, we want to establish the paths to the CSV file. Okay, so you can see we're getting the base directory path. Then we say we want to obtain the properties.csv, as well as properties embeddings.csv. This file is not yet existing, but we will create it once we create the embeddings. So properties.csv contains the property details. Then property embeddings.csv adds another column which will contain the actual vector embedding for the property. Okay, so then this code contains all the columns we will use to embed the property. Okay, so we will combine all of them into one paragraph so that you can embed it into a vector embedding that represents a single property. So that will contain the city, street address, home type, can be let's say single family house or a townhouse, etc. The description of the property, which is very critical, then the bedrooms and the bathrooms. Then in this code is where we combine all these columns we have obtained up here into one column, and that column we'll call it combined. Okay, so it's a combined column containing all the details we'll embed. So that will contain the bedrooms, bathrooms, home type, city, description, street address. And you can notice for each of those fields we describe the label first, home type, then we pass in the detail itself there. Okay, so then here we create the embedding itself. So we'll create a new column, call it embedding. Then the embedding column will contain the vector embedding. How do we generate the embedding itself? Is by applying this function called create embeddings to each of those values in the column called combined. So this function is a critical part called create embeddings, and I'll show you what it entails. So we are importing this from the file called functions.py. You can see here import from .functions. So you import create embeddings and cosine similarity. This we won't use in this video, but it's another way of performing a semantic search if we hadn't used Pinecone to do the semantic search. So if I go to functions.py, I can see the function create embeddings, okay? And it takes in a query. So it takes in, let's say, the user query or the combined details of the property so that you can embed. So how we perform a semantic search is this way. The user asks, I want a 3-bedroom, 2-bathroom house in the mountains. We take that query, then we embed it, okay? We have a vector embedding of it. Then we have the vector database containing all the vector embeddings for each of those properties. And a vector embedding is the paragraph containing all the combined details of the property. Okay, so we will do a semantic search comparing the vector embedding of the user's query against the vector embeddings of the properties. Okay, then how close the vector embedding of the user's query is to the vector embedding of the property will determine which is the most recommendable property to the user. So we have the user's query of what they want and all the vectors for each of those properties. Then the semantic search is just calculating the distance between the user query embedding and the property embedding. Okay, and the property embeddings are stored within the vector database. Think of the vector database kind of like a multi-dimensional graph that has, which in this case has 1536 dimensions. Then the vector embeddings are in different places within that specific graph. How we perform the search is now checking the user query embedding. We compare it to the first property embedding. Then we calculate the distance between the two embeddings, then return a score. Then we do the same thing for each of the properties within the vector database. A score will be generated for each of those similarity searches, checking the distance between the two embeddings. And the one that's closest will have a higher score, okay? And that's how we return the most recommendable property back to the user. Okay, so there are two ways you can create a vector embedding. One is using the OpenAI Python library, which is the simplest way to do it. And also the other way is just making an API call to the embeddings endpoint to get back a relevant embedding. Okay, so you can see I've imported the OpenAI Python library. I've saved here my OpenAI API key, which is covered, but on your side ensure you have it. Then here's how we insert it. So we do OpenAI.API key to insert the API key. Okay, then in this function we want to first get the query. It can be the query of the user or the property combined paragraph so that you can embed it. So this function will serve both purposes of embedding anything. Okay, then we want to replace any line breaks with an empty space. Then we create the embedding by running this function OpenAI.embeddings.create. Then we pass in the specific query we want to embed. Then we say we want to use this specific model. It's an embeddings model that we want to use. The different models you can use, specifically 3 of them, but this is very good. Text embedding 3 small. It's one of the latest ones, and it gives back an embedding that has 1536 dimensions. Okay, you could go with text embedding 3 large, but that gives you an embedding that has way more dimensions, more than 2000 dimensions. Okay, then we return the response, and the embedding will be within response.data, the first index, okay, within the embedding property. Okay, then the other way is just making an API call to this specific endpoint, which we get from the OpenAI documentation. Then we pass in our authorization, which is our OpenAI API key, which is a bearer token. Then we want to specifically say that the body has JSON data. Then this is the body that will send to the API. So you can notice we just need the model and the input that will be embedded. Same case to up here for the create embeddings function. We just needed the input and the model itself. So it's quite simple. So we convert the data into JSON string so that you can pass it on through the API. Then here is where we make the API call. So you'll ensure you've imported this library called requests. Over here I've already imported it. Then we do request.post. We post to this specific embeddings URL that we have here. We pass in our headers and the data that we want to embed. Then we get back the response and turn it into JSON. Then we get the data. The specific index is the first index where we'll get the embedding itself. Then we return back the embedding to this function. Okay, then this cosine similarity function, I won't touch much on it. I have it here because we used it within the video. I did a video where I was training on creating embeddings, the very basics on that, and there we were doing the similarity, the semantic search using the cosine similarity function. So you can see it takes in 2 vector embeddings, A and B, then it calculates the distance between the 2 embeddings, then returns a score for that. So now let's make a request to this specific API to create the vector embeddings and save it to the property embeddings.csv. So for that we'll use Postman. Here in the URL part I'll input my the URL of my server. So for that I'll just go back to IDX. Remember this tab where we had run the server. I'll copy this URL as is, go back to Postman, paste it in here. Okay, then to run the API, it's within the /API/create_embeddings, and I'll show you that. Here in the urls.py file, importing the functions that we'll use. So you can see I'm importing all the API functions, search properties, create embeddings, and configure Pinecone. Then I'm setting up the paths to each of those APIs. So you can see for create embeddings, I set it up there. So within the API, so /API/create embeddings. Then here in Postman, in the authorization, I need to generate an access token and paste it in here. So to get the access token from project IDX, I'll come back here and do Control G, then come here at the beginning and do that IDX. So exactly what I'm typing, the arrow sign, IDX, then I'll search through to get generate access token. I'll click on that, it creates an access token. I'll copy that, then come back here to my Postman. Auth type is bearer token, then here I'll just paste it in here. So it's a get request, so we don't have any body information, so I'll just send the request. So you can see it's taking a while because it's creating an embedding for each of the property records that we have. So you can see it's returned okay, meaning all the embeddings have been created. Then if I go back here to IDX, I can see a new file has been created called property embeddings.csv, which has that extra column called embedding containing all the vector embeddings. So now that we have the vector embeddings, we need to upsert them into a Pinecone vector database so that you can do the semantic search. Okay, so for that you need a Pinecone account. So go ahead and search pinecone.io. So if you don't have an account, go ahead and create an account. It's just a standard procedure. So you'll click sign up. You can sign up with your Google account, then fill out all your details. So in my case, once you sign up, you log in, then you'll enter your dashboard. So you'll go ahead and create a project. So for that, you'll just come here and create a new project. Then you can be able to get started. So a vector database stores the vector embeddings in something we call an index. Okay, so think of an index kind of like an instance of a database containing all the vector embeddings that we'll use. Okay, so for that we need to create an index within the Pinecone vector database. So for that, first you need your API key. So you'll come here and click on API keys, then create a new API key, copy it and save it somewhere because you'll use it within the project. So back here to IDX, ensure that you've installed the Python library called Pinecone client. So if you used the requirements.txt, you've already done that, but it's just doing pip install like that. Pip install, forgotten an L over there, pip install Pinecone client. Run this within your terminal if you haven't installed this. So we'll be using this to do anything in regards to Pinecone. So it's quite simple. So now I want to explain how Pinecone works. So we've said Pinecone is a vector database, okay? So for us to be able to upsert the vector embeddings that we have in the CSV into Pinecone, we need three things, okay? We need the property ID, the vector embedding itself, then the metadata. So in this case, metadata is the property features that we have for each of those properties. So for example, city, state, bedrooms, bathrooms, and the metadata come in very handy to ensure we are getting even more accurate semantic searches. So for example, if the user says, I want a 3-bedroom, 2-bathroom house within the mountains and has a swimming pool, we're already able to obtain that we need the bedrooms to be 3 and the bathrooms to be 2, okay? So we don't need to do a semantic search against all the properties within the vector database, even the properties that have 5 bedrooms or those that have 1 bedrooms. So first of all, we need to do what is called metadata filtering. So we first filter down based on the features we already know the user needs, that is 3 bedrooms and 2 bathrooms. Then after we've filtered down and gotten all the properties that match those requirements is when now we can do a semantic search based on the vector embeddings. So it ensures that we're getting more accurate responses, but also we're not wasting resources to do a semantic search on properties we already know won't meet the criteria. So that's why you need the metadata. So the ID, which is the property ID, the vector embedding, then the metadata, okay? So now let me explain the configure Pinecone API that will handle upserting the vector embeddings to Pinecone. So ensure you have your Pinecone API key over here. Then here we configure the Pinecone client. So we create an instance of the Pinecone client. So we'll use this specific library which we've imported up here. So you can see where we are importing the Pinecone library from Pinecone as well as serverless spec. So this is because we're using serverless indexes to upsert our vector embeddings. So there are two types of indexes you can use, serverless or pod, okay? So a serverless index is way better because first of all, it consumes less resources and is much more faster and like 50 times cheaper than using the pod based indexes, okay? So I won't go into the nitty-gritties of that, but just know serverless is the best option to use in this moment. Then here we set up the Pinecone index. So for this we explicitly say that we want our index name to be real estate index. Then the number of dimensions of the vector embeddings we'll upsert is 1536, okay? If I had my vector embedding smaller, something like 100 dimensions, I would have here as 100 dimensions, okay? Then this function handles creating the index itself. So the name of the index, we pass it in there, the dimensions, the spec, okay? So you can notice here we created the specifications of the index, which we'll use the specific cloud, which is AWS, and the region we want to host the index is US East 1. I think this is the only region we can use that is free, because at the moment we're using the free version. Then the metric we'll use to do the semantic search between the vector embeddings is cosine, okay? Then before connecting to the actual index to upsert the vector embeddings, we need to wait because it might take some time. So we'll run this while loop that will check, first of all, to check if the status of the index is ready. If it's not ready, so you can see if it's not ready, it will be pausing for 1 second, then checking again. So it will run the loop, check if the status of the index is ready. If it's not ready, it pauses for 1 second, then checks again. Pauses for 1 second, then checks again until the status turns to ready. Then it will exit the while loop and continue with the code. Then here we connect to the Pinecone index. So pc.index, then we connect to the specific real estate index that has been created. Then before upserting the vector embeddings to Pinecone, we need to create a data frame that contains the 3 columns we have stated. The first column is the ID, okay, which in this case is the property ID, then the vector embedding and any metadata we'll be using. Metadata part is optional if you don't have that, but is extremely important if you have it, because it will make your searches much more accurate as well as consuming less resources. So first of all, we want to obtain the data frame from the property embeddings.csv, okay, and save that to a variable called df, okay, meaning data frame, okay. Then we create a second data frame, which is going to be the new data frame that will upsert into Pinecone. So we will call it df2, and for this we're using pandas, which we have already imported up here. You can see import pandas as pd, okay. Then we want to create a column called id within the second data frame, and that will contain the ZPID. In this case, our property ID is in the column called ZPID within the property embedding CSV, okay. Then we want to ensure it's a string, so apply this function called string, which is an inbuilt Python function, because the ID of the vector has to be a string for it to work, okay. Then we have the vector embedding itself, so we'll create a column called vector within the second data frame. Then that will contain the vector embedding within property embeddings.csv. Then we want to apply the following function to transform each of the values within the vector into a float number. So if it was a string, ensure it's turned into a float data type for it to work. Then we finally create the final column called metadata, which will contain each of the property features we want to use for the metadata filtering, okay. So we'll want to filter down by the city, state, bedrooms, bathrooms, home type, etc. So you can see all that we are applying there. And how we want this to be structured is a Python dictionary containing the metadata name and the metadata value. So how this will be structured, let me just show you. So something like this, but now you'll add home type, description, street address. Then for each of the rows within our property embeddings, so each of the property records will have each of them to have that. So something like this, okay. So this is what we are trying to achieve with this specific function over here, okay. So that's the metadata. Then here is the part where we upsert the vectors to Pinecone. So you are running index.upsert, then we pass in the following vectors. So this is standard procedure for upserting to Pinecone. You'll say vectors is equal to zip. So we are using the zip function, which returns a list of tuples, and each of the tuples represent a single property record, okay. And a tuple is like just a list, but now you're not using the square brackets, you're using parentheses, okay. So for that, it will look something like this. So something like this. So you're seeing it's a tuple which is in parentheses, okay, and the first part is the ID itself, the second part is the vector embedding, and the third part is the metadata that we'll use. So for each of the records within property embeddings.csv, we'll get something like this, okay. So that's why the zip function comes in. Then we'll upsert it into the index. Then if it's successful, we return a response saying successfully configured the Pinecone. So for this, let's run the API from Postman to upsert the embeddings into Pinecone. So here in the URL part, we'll change this from create embeddings to configure Pinecone. Then we send the request. So it's saying 503 service unavailable. So let's see this terminal. You see that's saying syntax error. So it means we added some code that was not meant to be there. So we'll delete all this line. Okay, and yeah, that's it. So that should work. So let it reload, then run the server again. So we run the server, successfully configured Pinecone. So let me go back. Then if I go to Pinecone, then I go to database, then I reload this, I should see my index created, okay. You can see there you have it. Then when you click on the actual index, we should see the details. So you can see the metric we're using, the dimensions, all those details. And you can see record count. We have the 30 properties that we had in the CSV. Then if I scroll down here to see the actual records, you can see we have the ID of the property. In the values, we have the vector embedding. Then we have the metadata, for example, bathrooms 3, bedrooms 3, the city, the description. If I show 3 more, you can see all the metadata that we have uploaded, okay. So that's working. So if I go back here to IDX, now we can be able to perform a search for the properties. So for this, I'll show you the search properties API that handles performing the search. So this is a post request because we're passing in the user query that needs to be embedded to do the semantic search, okay. So first of all, we obtain the question itself and the metadata. So any feature that they've requested for within the user query. So like something like bedrooms 3, bathrooms 4, city equal to Arizona, something like that, okay. Then we embed the actual question using the function create embeddings, which we already touched on, okay. So this I've commented out because once we run this from Voiceflow, we'll need to use this function of literal evaluation to obtain the actual metadata, okay. So but when we are running this from Postman, we can just use it as is. Okay, then this function works to transform the metadata that comes in into a more usable filter dictionary. So it's not a must, but there are two ways you can have your metadata filters. So it's a dictionary containing something like, so let me show you the structure, something like this. Okay, bedrooms 3, bathrooms 2. So that's how a filter can be. But the other way, which is normally recommended within Pinecone's documentation, is having the filters using these specific filter operators. You can see something like this, equal to, and the likes. Okay, so to be able to see the actual filter operators, just go to the Pinecone documentation, search something like metadata filter operators, then you're able to see that. Okay, but in this case it's not a must. Okay, I have to emphasize on that. So when we run the function, this function on the metadata, it will give back something like this. So you see, it's the same thing, but now we have the filter structured this way. Okay, so then here is where we transform the metadata into this structure. So we get the metadata, pass it into the function itself. Then we configure the Pinecone client. Okay, so we pass in our API key, then the index name, real estate index. We connect to the actual index and save it to this variable. Then we perform the semantic search. So you see we're doing index.query, then we pass in the vector embedding that we want to search through. So this is the embedding of the question itself, the user's query. Okay, top k is equals to 3. This means that we want to return the 3 most recommendable properties. So we can even increase it to something like 5 or 10. So it will return the 10 most recommendable properties that are closest to the user's query. Okay, then we pass in the filter, which will be the dictionary we created up here. Then we want to include metadata equals to true, so that we can see the metadata when we run a request from Postman. Okay, then we'll disable this when we are working with Voiceflow, because we don't really need to see that. We only need to get back the ID of the property. Okay, so that's critical. Then here we return the response that we have gotten from searching the properties and turn it into a dictionary so that we can see it. Okay, so let's run a request from Postman so that you can see this practically. So I'll change this to search properties. Okay, then it has to be a post request. Then in the body, it's raw JSON. Then I'll pass in the following body. So the text that needs to be embedded, this is the user's query and the metadata. Okay, so you can see 3 bedrooms and 2 bathrooms. So now let's run this request and see it practically. There you have it. So you can see these are the matches that we get back. So let me expand this. So you can see the ID, okay, the property details, so the metadata, bedrooms 3, 2 bathrooms, so it's able to get that accurately. Then in the description, you can see here, located in the prestigious mountains. So this is what the semantic search was able to get back accurately. Okay, then you can see for the other properties, the property ID, the metadata itself. Okay, then in the description, we're able to see nicely updated home located in the mountains. So it's getting that correctly, and the other property. Okay, now we go into integrating the functionality into Voiceflow. Okay, so for this I'll go to the by property functionality, the by property workflow. So as I've mentioned, I won't go into the nitty-gritties of Voiceflow here, because this we have already done a video on, so you can go and check that out, building the most powerful real estate chatbot, in my YouTube channel. Okay, but over here, this is the workflow that handles that. It is led here from the home workflow, and in this home workflow we have just a first message that asks, hello there, I'm Zawadi, your friendly AI property assistant, how may I help you today? Then you have a listen step to listen for any intent from that. Then it leads it on to the different workflows, let's say buy property or selling a property. Okay, so we go to the buy property workflow. So the workflow begins with a set AI step that works to extract the metadata from the user's query. Okay, so I'll just enter the set AI, quickly skim through it. So you see we provide the conversation history, generate a JSON object from it. Then if you go to the prompt settings, okay, so whatever is extracted will be saved to a variable called JSON metadata. So we want to use GPT 3.5 Turbo and bring down the temperature to as low as possible. Set the max tokens to the default. Then in the system prompt, you can pause and read through it. But the main point is we give it some examples down here. So for example, if the user says, I want a 3-bedroom, 4-bathroom house in Lincoln City OR, the assistant will give back a JSON object containing this city, state, bedrooms and bathrooms. So we do that for the other examples. Then we caution it down here. For example, note that common words like mountains, pool, hills don't count as a city name. So I was noticing it was messing it up when I was testing it out, so I give that cautioning. Then I provide the conversation history, then wait for the assistant to give back the JSON object. Okay, then we can do a quick preview. So I do AI preview here, then I say something like that. I want a 4-bedroom 1-bathroom house, so let's generate. So you can see it gets back a JSON metadata, bedrooms 4, bathrooms 1, so that's working. The next is just JavaScript, which isn't really necessary. I was just using it for testing purposes to see the kind of data that is brought back by the AI. Okay, the next is the function that will handle making the API call to our APIs to do the semantic search. Okay, so you can see it takes in 2 input variables, that is the user's query that is within the last utterance variable, then it takes in the JSON metadata which is within this variable. Okay, then it gives back the properties JSON that we get back from running the semantic search. Okay, then saves it to a variable called properties JSON. Okay, so I'll enter the function and quickly skim through it. So first of all, standard procedure is obtaining the user query JSON metadata, so the input variables. Then we try, so we're having a try catch block. Try making an API call to do the semantic search. If wherever in the function you run into an error, we're able to catch it down here. So catch the error, then exit the function through the path of error, then return these traces. Okay, so the trace of type debug, and we pass in the error message. Okay, so the debug message will be seen when we are testing it within the Voiceflow canvas, but once we deploy it, we don't see it. So the small gray debug messages that you normally see, but in the demo notice it wasn't there. Okay, so here we'll make an API call to IDX. So this is the same URL we ran with from Postman. Okay, so it's a post request. Then in the headers we pass in the content type. So the content type will be application/JSON. This is saying that the body data is JSON. Then we pass in the authorization token. Okay, then we get back the response, turn it into JSON. Then we want to check if actually properties were brought back. So we'll check that within JSON response dot matches. If the length of the array itself is greater than 0, means that it's gotten back some properties. So that is successful. So we'll exit the function flowing through the path of success, then give back the specific JSON response back to the function. Okay, else if the JSON response was 0, means it didn't get back some properties, will flow through the path of no properties. And you can see we explicitly state our paths over here. So we have 3 paths: success, error, and no properties. Okay, and down here we've already explained. So it's a simple function that does that. Back to the workflows. So if it successfully retrieved the properties, it will flow through this path, come to the JavaScript block down here, which simply turns the JSON response that we get back. It comes in as a string, but to be able to work with it, we need to turn it into a JSON object. So we use this JSON.path to do that. Then we want to extract the specific property IDs so that we can use those property IDs to call our Airtable database and give back all the details on that specific property, including the image itself and any other feature that we'll use later on if the user wants to ask some questions. So remember, when you click learn more on this property, it's able to ask, the user is able to ask more questions on the features of the property. Okay, so we need to extract the property IDs for that. So this function does that, extract the IDs, takes in the properties JSON, okay, then loops through each of the properties that have been returned back. Okay, so let me expand this. Then it pushes an ID to this empty array that we have created down here. So that we get from the properties JSON dot matches, we get the specific index we are currently on in the loop. Then we want to obtain just the ID itself. Okay, then we return the IDs from the function. Okay, so this IDs array, or rather a list, depending on what you want to call it. Okay, then we save the IDs to a variable called property IDs, which we have already created within our Voiceflow project. But if there's an error or no properties gotten from the search, we'll flow down here. So you can see down here, let me just zoom in. Error searching for properties, kindly try again later. And the other one is currently we don't have any properties that meet your criteria. Okay, but once we have gotten the property IDs, we need to generate an Airtable formula that will obtain all those properties that we have within that list of IDs. Okay, so for that we'll have a set AI step called Airtable formula generator. Generate an Airtable formula from the following property IDs. Then we pass in that list of IDs and save whatever is extracted to a variable called Airtable formula. Then in the prompt settings, the system prompt has the meat of actually generating that. So you can pause and read through the prompt, but the critical part is the examples we give over here. So if the list is this, give back the Airtable formula as this, or where the property ID is this, or where the property ID is this, and so on and so forth. Okay, so that's working. The next, we make an API call to Airtable to be able to get back the properties. Okay, so here I pass in the filter by formula. I pass in the Airtable formula that we have. So I won't go into the nitty-gritties of making an API call to Airtable, because I've already touched on that on several videos that I already have, as well as this real estate chatbot video that I've recommended to you. Then here we pass in our access token. Okay, then here in parameters we specifically say that we don't want all the fields within that database, but we want only the city, state, price, HTTP URL, and all this. Okay, then we save that to a variable called API response, and we get that through response.records. Okay, so the API response that comes back, we want only to access the records property, because that's where the property records are stored. Okay, then next is this JavaScript block that will work to generate a payload that will dynamically render these properties we get back from Airtable into a carousel within the chatbot. Okay, so we make an API call to Airtable, get back the property records, then render them as a carousel. So for each property it will have its own card, kind of like what you saw in the demo. So to generate that, we'll create an empty cards array, so an empty variable. Then we loop through all the records within API response. Then we generate an object representing a single card, and a single card is a single property. Okay, so first we want to obtain the address. Okay, then we want to get the price in US dollar format. Okay, then here we'll push a card object to that empty cards array we had created. So a card object has an ID, a title, a description, the URL to the image itself, and some buttons. Okay, so I explicitly say that. So the street address will be the title, then the description will be the price, bedrooms, the bathrooms, etc. Then we have the image URL there and some buttons. So we have 4 buttons. One is to view on Zillow, and when they click on view on Zillow, the following request will be executed. So it will flow through the path of view on Zillow, and you'll see these paths within the custom action block that will come after this JavaScript block. Okay, so the request type of the button should match the path within the custom action block that will dynamically render the carousel. Okay, so view on Zillow is there, and the payload is the property ID. Then in the actions, we want to open a URL, and that URL is HTTP URL, which is the URL to the actual property on Zillow. Okay, then we have the house tour video, the view on Google Maps, and learn more on this property. So I'm quickly skimming through this because I've already touched on it in the previous video. Then here we have the payload itself. Then we want to turn it into a JSON string, because the custom action body only accepts a string. So I minimize that. Then after this is the custom action block. So you can see the custom action name is carousel, because that's the trace type we are trying to render. Then in the action body, we pass in that restructured API response, which is a string. Then we have the following paths. Okay, so remember, these are the paths that match the request type of each of those buttons. Okay, then if they click on either of them, the path will flow on to that specific function that handles that. So if they click on house tour, they'll go to the house tour block that handles displaying the YouTube video. Then if they click on Google Maps, they'll go to the block that handles displaying the Google Maps, etc. So go and watch that video. It teaches you everything that I do on this specific project. Okay, and yeah, that's it from me. So hope you've been able to learn on how you're able to work with vector embeddings within Pinecone to be able to do a semantic search on your real estate properties. So it's quite powerful compared to the previous video which I had done, which we were doing the property search based on an Airtable formula. Okay, the limitation with just working with the Airtable formula to do the search is that if the user says something specific like I want the house to be in the mountains, the Airtable formula is not able to bring back properties that match such a detail. So doing the semantic search through the vector database helps in giving a more recommendable property that is more accurate to the user's query. So it's quite powerful. And yeah, that's it. All resources we used within this video, check out the link in the description to the GitHub code as well as the Voiceflow template so that you can work with it. If you want to work with our team to build such powerful systems, whether it's an AI chatbot, voice bot, or automating any repetitive tasks within your business, there'll be a link in the description to book in a meeting with our team. Till next time, stay survey. Peace.